In this video, I'm going to go over a couple of the homework problems. This is problem 14 from problem set 2.3. This is the problem that was asking for us to write a model for the steel plant. This is our table of data that we were given. And we were given more information here on the cost of the materials and the labor that would be used, and then how much the output for each process could be sold for and the profit that could be made there. We were asked to maximize the net income. And then this suggestion was given on how to handle the income for the side product. So I wrote out the table that was given above, but then I added the constraints of that we had a maximum of 350 hours of labor, 2 tons of the ore. So the constraints up here were given in tons and hours, and so I just went ahead and converted everything to pounds. So 10,000 pounds of ore. We did not have a limit on the amount of coal that could be used, or the amount of steel produced or a side product that could be produced from each process. And then I added a column for the cost. So this is the cost of labor per hour, the cost of ore per pound, the cost of coal per pound. And then this is the income that would be made, the profit off of the steel per pound and the side product per pound. So the tricky part was that you were only going to make this profit on the first 2,000 pounds of side product. After that, the profit would be zero. So I chose these variables to use x1, x2, x3, and those represent the number of hours per week that we would run process 1, 2, or 3 respectively. And then I split up, as hinted in the book, the suggestion to split up the amount of side product produced to S1 and S2. So S1 is the first 2,000 pounds, and then S2 would be anything over 2,000 pounds that was produced. So in order to calculate the net income function, I started out, and at first I just wrote out a cost function. So what was it going to cost to run each process? So this is the cost. You'll notice it correlates to the table. The cost of $15.75 per hour, and it was going to 8 hours for every. It took 8 hours of labor for every 1 hour to run process 1. 11 hours for process 2, 7 for process 3, and so on. So those need to all be multiplied out, and then the cost of your ore and coal as well. So this is the function, and then I just simplified it. I went ahead and multiplied all those out and combined like terms to get this cost function here. Then I calculated the income function. So the income function I used, I kind of disregarded the fact that we were only going to make profit off of the first 2,000 pounds of side product. So I took these two values here that we were going to make per pound, and I multiplied those out similar to our cost function here. And I simplified it out. And then I went on to calculate the net income. So that should be your profit minus your cost. So I took this value, 179.3975 minus the 131.17 to get this value for. So this is how much would be made off of process 1 for every hour of process 1, for every hour of process 2, and then process 3, and so on. But this is not entirely accurate because we did have that restriction that we were only going to make profit on the first 2,000 pounds of our side product. And this is calculated in, when I used the income function here, as if the pounds of side product could be unlimited. So then I went back, and since I was going to constrain S1 and S2 in the constraints here, I said S1 has to be in between 0 and 2,000, so that's the first 2,000 pounds, and S2 is going to be anything over that. And so that is where these two lines of the constraints come from here. And so then your total side product, because this is we're gonna get 35 pounds per hour for process 1, 15 pounds per hour for process 2, 75 pounds per hour for process 3. Those have to equal S1 and S2. So that allowed me to just go into my net income function and just subtract off solely what would be made for S2, which is going to be the overage, anything over 2,000 pounds. And then here are the other constraints. Other constraints where we had a limited amount of labor that we could use. So this was again from our table here. We could 8 hours of labor for process 1, 11 for every hour of process 2, 7 for every hour process 3, and it had to be at most 350 hours. And then I did the same thing with the ore here, this constraint, but we did not have a limit on the amount of coal that could be used. So we didn't have to write a constraint for that. And then it also told us in the problem that we could, any one process could not be used for more than 40 hours in 1 week. So not only do these variables here have to be positive values, they have to be less than or equal to 40. And then I also made sure to include that S1 and S2 had to be greater than or equal to 0. So that is problem 14 of 2.3. That's a production model example. And then problem set 2.4 was over the transportation model. So number 7 was kind of similar to that problem in that we had restrictions on the surplus that could be sold from the different centers. So again, I just took the table that was given and I added, well, this is the exact same table actually. I just rewrote it out so I could have it to refer to. And then I could have added a line also for the profit that could be made from selling the surplus. That probably would have been helpful. So I set my variables as suggested in the videos in the book. So X sub ij is the number of units that was going to be shipped to store J from center I. So I, of course, has to run from 1 to 3 because we have 3 centers, and then J would run from 1 to 4 because we have 4 stores that we're shipping to. We were told that we had to ship everything from center 1. It had 225 units. But centers, distribution centers 2 and 3 could have surplus. We did not have to ship everything from there. And we were asked to minimize a cost. So since we could sell the surplus from centers 2 and 3, I included extra variables. So I just used Y. Y sub 2 is going to be the number of surplus units at center 2. But then center 3, I needed 2 variables. So I just chose Y sub 3 1 and then Y sub 3 2. I could have done probably Y sub 3 prime and Y sub 3 double prime. May have made a little more sense, but that's just what I chose. Because there were different amounts of profit that could be made per unit sold. So up to the first 30 units, I believe we were going to make $27 of profit per unit, and then it was only 23 after that. So that needed to be split up so that we could account for the difference. So our cost function is just going to be the cost of shipping. So this was it cost, I think 40, I think it was dollars to ship from distribution center 1 to store 1. And so it's from so on. So I just literally totaled up basically every cell inside here, multiplying it times the appropriate variable, summed those together. And so that's how much it was going to cost us, but we really have to subtract off the profit that could be made from the surplus. So that's where these variables came in. So we could subtract off $25 for every unit at center 2 that was sold, that we didn't ship from center 2, that we sold instead. That would decrease our total cost. And so then again, I also subtracted off $27 for the first 30 units that could be sold at center 3, and then we would only make $24 for, was that right? 24? It should have been 23. That's a mistake, actually. That's a mistake. That should have been $23 right here. This should be 23 instead of 24. So we could make $23 for every unit that was sold as surplus at center 3. So then here are the constraints. So basically, from everything that was produced at distribution center 1 had to ship out. So we had to ship all 225 units. So whatever we ship to those 4 stores has to equal 225. But then For distribution centers 2 and 3, it just has to be less than or equal to. The maximum amount of units we had was 300 and 375. So we just had to make sure we could ship up to that or less than those. And then it was a requirement that every single store, whether it came from distribution center 1, 2, or 3, it had to total 200 units that were shipped to each store. So we were shipping a total of 800 units out to those to be divided among those 4 stores. And then we have to have the constraints, of course, that what we're shipping has to be a positive value. So no non-negatives here. So everything needs to be greater than or equal to 0. But then we have to add in the extra constraint that what is shipped, the first 30 right here, it has to be less than or equal to 30. Y sub 3(1). So that accounts for you making the $27 off of the first 30 units of surplus that we have. And then the rest we would only, this again should be $23. So that's how that one could be set up. And just a note here that I did write everything out in like the long manner, but I could have just said, like, for instance, with this constraint here, that x sub I 4 equals 200. So I could have used this notation here. I could have rewritten my constraints in this manner, and it would have just saved some time and some space. So just keep that in mind. It is best to use that notation.